Hello friends, so today we start a tutorial for chapter Uniform Plane Wave Propagation. So here we will solve total 4 numericals which is based on our chapter. So in last lecture I have given one assignment which is based on power and Poynting vector. Okay, so the first question is say that in a non-magnetic medium vector E is equals to 4 sine 2 pi into 10 raised to 70 minus 0.8x az volt per meter. Find relative permittivity, intrinsic impedance, second time average power which is carried by wave, and third the total power crossing 100 centimeter square of plane 2x plus y is equals to 5. Okay, so first of all we have to solve the first question. So the first question is based on power and Poynting vector. Okay, so here what we have to find, we have to find out first what is epsilon r and what is intrinsic impedance. Okay, so solution of first question. In a non-magnetic medium, okay, it is given that the medium is a non-magnetic medium. Non-magnetic medium, it indicates that the relative permeability is 1. Okay, and if the medium is non-electric medium, suppose instead of the non-magnetic, if it is given that non-electric medium, so epsilon r is equals to 1. Okay, so here non-magnetic medium, so mu r is equals to 1. Vector E is given, vector E is 4 sine of 2 pi into 10 raised to 70 minus 0.8x az unit vector volt per meter. Okay, now we have to find out relative permittivity and intrinsic impedance for that medium. Okay, so now this equation is given. Okay, so we have studied one standard equation when we have derived the wave equation. The standard equation for electric field is that we have already studied E of zt, which is a function of space and time, is E0 e raised to minus alpha z into e raised to j omega t minus beta z into ax volt per meter. Okay, so this one is a standard equation for electric wave. Okay, so here our assumptions is electric field or electric wave is present in which direction? X direction. Okay, similarly for the magnetic wave which is present in y direction, and what it indicates, this z is indicate the propagation direction of wave. Okay, so and what is alpha? Alpha is a attenuation constant. E0 is its maximum value. Okay, now I have to simplify this equation. Okay, so here if you notice, it is e raised to j theta terms. E raised to j theta, it indicates it is not e raised to j theta, it is cos theta plus j sin theta, real part and imaginary part. So our wave has contains only real part, only imaginary part, or both of the part. Okay, so I can write this term, as cos omega t minus beta z plus j sin omega t minus beta z. Okay, so we can write in this way. Clear? So if I have to compare these two equations, okay, the data which is given in our question and our standardized equation. Okay, so in this equation the electric field is present in which direction? In x direction, but in our data electric field is present in z direction. Okay, the propagation direction is z direction, but here the propagation direction is x direction. Okay, so I have to simplify this equation. Okay, so it is E0 e raised to minus alpha z. Suppose for example we consider the our electric field is present in sine. Okay, that means only imaginary part is present, so this sine omega t minus beta z into ax. Okay, so these two equations look like same. Okay, but here the difference is, in this case electric field is present in z direction, here it is in the x direction. The propagation direction is x direction, propagation direction is z direction. Okay, so this data is given in our question. Okay, so we will solve this question based on our given data. Okay, so now I have to compare these two. So if I have to compare these two, so what is omega? So omega is given, which is omega is equals to 2 pi into 10 raised to 7. What is beta? Beta is equals to 0.8. Electric field is present in which direction? Z direction, and propagation direction is x direction. Okay, clear? Now what we have to find? Read the data. We have to find out the relative permittivity. We have to find out relative permittivity. Okay, and intrinsic impedance. Okay, so now we know that beta, which is phase constant, is equals to 2 pi by lambda. Okay, I have to multiply with f at the numerator and at the denominator. Clear? Okay, so it is 2 pi f, which is nothing but omega, and lambda f is nothing but my velocity. Okay, so beta is equals to omega by velocity v. Clear? Okay, so value of beta is given, value of beta is 0.8, value of omega is also given, which is 2 pi into 10 raised to 7 divided by v, velocity. So velocity v is 2 pi into 10 raised to 7 divided by 0.8. Okay, now here this electric field is present in non-magnetic medium. Okay, that means mu r is 1 but epsilon r is not 1. Okay, that means the speed of electromagnetic wave is somehow less than the speed of electromagnetic wave in air, in free space. Okay, so what is v? What is velocity? Velocity is 3 into 10 raised to 8 divided by mu r epsilon r is equals to 2 pi into 10 raised to 7 divided by 0.8. Okay, from which equation we have to write this velocity? We know that velocity v is equals to 1 upon under root of mu into epsilon. What is mu? Mu is mu 0, mu r, epsilon 0, epsilon r. We know the value of mu 0, 4 pi into 10 raised to 7. We know the value of epsilon 0, 8.854 into 10 raised to minus 12. If I have to substitute this value, so it is 3 into 10 raised to 8 divided by under root of mu r into epsilon. Okay, so we have to put this one. Clear? So now here value of mu r is known. Okay, it's a non-magnetic medium, so mu r is equals to 1. So if you put mu r is equals to 1, so only epsilon r is unknown. So by using a calculation, we'll find value of epsilon r is, using calculator you can find it, 14.59. Okay, so we'll get our first answer, epsilon r, which is relative permittivity, which is 14.59. Okay, so here answer is 14.59. Relative permittivity is 14.59. Okay, second is intrinsic impedance. Okay, so we know that the equation of intrinsic impedance. What is the equation of intrinsic impedance? Equation of intrinsic impedance is under root of j omega mu upon sigma plus j omega epsilon. Okay, so now the question is, what is the value of sigma? Why the sigma is not given? Okay, but if you compare these two equations, the first equation, okay, and our standard equation, if I have to compare these two, okay, so this term is important for us. Which term? E raised to minus alpha z. Okay, here e raised to minus alpha z term is not present. It means that value of alpha is 0. So e raised to 0 is 1. So value of alpha is 0. What is alpha? Alpha is attenuation constant. So here value of alpha is 0. For this medium, alpha is 0. Alpha is 0, so it indicates the conductivity of this medium is 0. Okay, so that is why conductivity of medium is 0. So it is j omega mu, conductivity is 0, j omega epsilon, so it is only mu by epsilon. Okay, what is mu? Mu is mu 0 mu r, epsilon means epsilon 0 epsilon r. Okay, so eta is, if I have to put the value of mu 0 epsilon 0, so it is 120 pi. Okay, under root of mu r is 1, epsilon r is 14.59. Do the calculation. Okay, so your answer is 10 pi square, or it is 98.7 ohm. Okay, so intrinsic impedance for this medium is 98.7 ohm. Okay, clear? Well, now next thing is time average power carried by the wave. Okay, so here we have to find out the time average power that we have discussed in last video lecture. What is time average power? Okay, so this one is my time average power. Okay, this equation is based on the time average power. Okay, total time average power crossing the surface, but this one is my time average power. So this E0 square e raised to minus 2 alpha z upon 2 eta into cos theta n. But here the medium is a non-magnetic medium. Okay, and if I have to compare here, so alpha is equals to 0, attenuation is 0, so conductivity is 0. Okay, so attenuation 0, attenuation constant, alpha is equals to 0, so e raised to 0 is 1. So only which term is present? E0 square by 2 eta term is present. What about cos theta n? What is theta n? Theta n is nothing but the angle which is offered by the intrinsic impedance, but here intrinsic impedance has only real value, so angle offered by the intrinsic impedance is 0. So if I have to put theta n is equals to 0, so cos 0 is 1. Okay, so time average power is E0 square by 2. Okay, so this number 1. A. B. The time average power carried by the wave, the time average power carried by wave is P, capital P average is equals to, generally we have to write E cross H. Okay, so this is a vector quantity. You can write in this way, E cross H, and this one is okay, 1 by T integration 0 to T. Okay, P of ZT into dt. Okay, we have to write all okay in this way. So it is E0 square. Okay, it is nothing but E0 square by 2 mod of eta. Okay, so E0, what is E0? E0 means its maximum value, which is 4, and square, so it is 16 divided by 2 eta. Eta is given 98.7. So 2 into 98.7. Do the calculation. Okay, so answer is 0.081. okay, so 81 milli. So answer is 81 milliwatt per meter square. Milliwatt per meter square. Okay, clear? So here time average. Okay, so time average power carried by the wave, which is, or you can say this pointing vector. Okay, which is a function of z. It is, answer is 81 milliwatt per meter square. Power density actually. Okay, clear? Watt per meter square. Okay, now the question is, in which direction the power is, okay, in which direction the power is present? Okay, or you can say in which direction the wave is propagate. So here electric field is present in which direction? Electric field, okay, electric field is present in x direction. Okay, sorry, in the z direction. Electric field present in the z direction. Which one is the propagation direction? The propagation direction is x direction. Okay, so we can say that the propagation direction is x direction. So this time average power which is carried by the wave is in the x direction. So this ax, 81 milli ax watt per meter square. Okay, next, number C, the total power crossing 100 centimeters square of plane 2x plus y is equals to 5. Okay, so here area of plane is given. Here area is given, which is 100 centimeter square, and plane is also given, which is 2x plus y is equals to 5. Actually it's the equation of plane. 2x plus y is equals to 5. This plane is present. Actually for z is equals to 0, this plane is present. Okay, so z term is not there, only 2x plus y is equals to 5 term is there. and this one is the area of plane 100 centimeters square. Now we have to find out the total power crossing this plane. 2x plus y is equals to 5. Okay, I will give you one assignment that draw this plane 2x plus y is equals to 5 in Cartesian coordinate axis x, y and z. Okay, so now now we have to find out the total power. We have not find out the power density, but we have to find out the total power. Okay, so now total power pt is equals to the surface integration of p average power into surface ds. We know that surface is a vector quantity, line is a vector quantity, but the volume is scalar quantity, so I have to take surface as a vector quantity. Okay, so integration. So now p average, which is given 81 milli means into 10 raised to minus 3, in which direction? In ax direction, dot, okay, it's a dot product, so it's a dot ds. What ds is indicate, and it's a integration, it's a closed surface integration, it's a closed surface integration ds. Okay, so it is nothing but total s total means total area into its direction an. Okay, I will explain you what is this. So this s, okay, s into an, which is integration ds. Okay, again I have to pick up this one. Okay, so see here, integration ds. Okay, what integration is indicate? We know that suppose this one is one type of okay, it's a one surface, so actually I have to divide this surface into a very small portion, okay, into equal portion. I have to take only one portion and it is ds. Okay, and if I have to do the integration, so it is nothing but the overall surface area, which is s. Okay, so it's a scalar quantity, it indicates the area and the vector which is perpendicular to this surface. So this one is the vector which is perpendicular to the surface an. Why I have to write an? N is indicate is a normal vector. Normal means the perpendicular. Okay, and we know that the surface direction is always perpendicular to that surface, that means normal to that surface. So this a into n. Okay, this integration means I have to consider the total area. Okay, so total area is s and this vector means this a n. Clear? So that is why I have to write s into a n. Clear? So now what is s? S is given 100 centimeters square. Okay, so this 81 into 10 raised to minus 3 ax into 100 centimeters square. 100 into centimeter means 10 raised to minus 2, but 10 centimeter square means 10 raised to minus 4. Clear? And the most important thing is an. An means the unit vector which is perpendicular to the surface, and the surface is given by 2x plus y is equals to 5. So now what we have to do, we have to find out a unit vector which is perpendicular to this surface. 2x plus y is equals to 5. Okay, so first of all we have to find out one vector which is perpendicular to the surface 2x plus y is equals to 5, and then we have to find out the unit vector. So how can you find out it? So see here, the surface is given 2x plus y is equals to 5. Okay, so here surface is given by 2x plus y is equals to 5. This surface is a function of x and y. Okay, so for example I would write is f of xy is equals to 2x minus y minus 5 is equals to 0. Okay, so it's a surface equation. Okay, not 0, but it is 2x plus y minus 5. Okay, so it's a surface equation. Now the vector which is perpendicular to the surface is nothing but I would take del into f. Okay, it's a gradient operation. So if we find out any vector which is perpendicular to the surface, I have to take a gradient operation of that scalar quantity with del operator. Okay, so what is del? Del is del by del x ax plus del by del y ay plus del by del z az into f. Okay, and f is given to x plus y minus 5. Do the partial derivative, so answer is 2x plus ay. Okay, so this dial into f, and it is nothing but the vector which is perpendicular to the surface. But actually what we want a unit to vector which is perpendicular to the surface. So unit vector which is perpendicular to the surface is the vector upon its mode. Okay, so it is nothing but 2ax plus ay upon under root of 2 square plus 1, so this 5. Okay, so it is an, so we can write in this way. So this 81 into 10 raised to minus 3 ax dot product with 10 raised to minus 2. Okay, 2ax plus ay divided by root 5. Okay, now it's a dot product. Okay, first of all we have to take all the scalar quantity. Okay, so 81 into 10 raised to minus 5 divided by root 5. Now this ax dot ax 1, ax dot ay 0, so this only 2ax dot ax. Okay, so if you do some calculation, okay, and using calculation we will get answer 724.5 microwatt. Okay, so this one is the total power which is passing through the given surface area 100 centimeters square. Okay, so we have finished the first assignment, the first numerical, okay, which is based on the non-magnetic medium. Okay, now let us discuss the second numericals. Okay, so second numerical say that in a free space the vector is given, vector h is equals to 0.1 cos 2 into 10 raised to 8t minus kx ay ampere per meter. Okay, see, the ampere per meter is a unit of electric field intensity. Okay, find k, wavelength lambda, total time period t, and the time t1 it takes the wave to travel lambda by 8 distance. Okay, it's very easy. So similarly same wave, okay, here which quantities are given, only wave is given, h is equals to h vector is equals to 0.1 cos 2 into 10 raised to 8t minus kx ay ampere per meter. Okay, so the wave is in which direction? This magnetic wave in the y direction, and the propagation direction is x direction, positive x direction. Keep in mind, if in the example, if suppose it is plus sign instead of the negative, suppose it is plus sign, so the wave propagate in negative x direction, but here it is given negative sign, so wave propagate in positive x direction. Okay, so again I have to compare it with our standard equation. Our standard equation for magnetic field intensity, which is a function of space and time, it is h0 e raised to minus alpha z. Okay, I have to write cos or sine, you can write anything, minus beta z into ay ampere per meter. Okay, this one is my standard equation. Okay, so here value of alpha is equals to 0, value of alpha, okay, why? Okay, so but obvious, because it's a free space, so for the free space there is no attenuation, so value of alpha is 0 and the conductivity is also 0. Now just compare it. So what is omega? Omega is 2 into 10 raised to 8, so here omega is given, which is 2 into 10 raised to 8. Beta is k, beta is equals to k, and we have to find out first k, and k is equals to nothing but 2 pi by lambda. Okay, so this 2 pi f by lambda into f. 2 pi f means omega, lambda into f means velocity v, and it is a free space, so we know that in the free space the velocity of wave is 3 into 10 raised to minus 8. Okay, so beta or k is equals to omega 2 into 10 raised to 8 and velocity 3 into 10 raised to 8, because for the free space relative permittivity and the relative permeability value is 1, it's unity. Okay, so it is nothing but 0.667 beta. What is the unit of beta? Radian. Okay, So radian per second. Clear? It's a beta is a phase constant, so it's a radian per second. Clear? Next, so this is beta over k. Next is lambda. Okay, lambda is wavelength. How can we measure the wavelength? It's very easy. Okay, again we have to use this same equation. Beta is equals to 2 pi by lambda. So what is lambda? Lambda is equals to 2 pi by beta, and beta we have already found out. Beta is 0.667. Okay, so it is 2 pi by 0.667. So lambda is 9.42. Lambda is equals to 9.42 meter. Okay, actually it's not a it's a radian per meter. Okay, not second, it's a radian per meter. Clear? So this is a meter. Clear? Next, capital T. We know that omega is equals to 2 pi by capital T. So what is capital T? Capital T is equals to 2 pi by omega. Okay, this example is very easy. So this 2 pi into 2 into 10 raised to 8. Okay, do the calculation. So it is 31.42 nanosecond. Okay, clear. So and B, the time t1 it takes the wave to travel lambda by 8 distance. Okay, so here the wave is propagated. It is given that the wave is propagated in free space. Okay, with which velocity? With 3 into 10 raised to 8 meter per second velocity. Okay, so for time period, so we can say that if t is period of wave, if capital T, okay, that we have to already find out capital T is a period of wave and it takes t second to travel a lambda distance. Okay, so to travel a lambda distance, it will take how much time? It will take total capital T time. So to travel lambda by 8 distance, it will take how much amount of time? Okay, and it is nothing but my t1. So the small t1 is lambda by 8 into t by lambda, so it is t by 8. So it is 31.42 divided by 8. Okay, so answer 3.927 nanosecond. Clear? So it's very simple example. Okay, next example number 3. Next example 3. Okay, so example 3 say that it's very it's important example. Okay, so in example 3 it is example 3 say that in a lossless medium, okay, the medium is given, the medium is lossless medium. Lossless medium means conductivity is 0, attenuation is 0, for which eta is given is a 60 pi, mu r is 1. Mu r is 1 means a non-magnetic medium. Okay, but epsilon r is not 1. Okay, we have to find out the epsilon r. Okay, mu r is 1 and h is given. Okay, if you look here, h is given. Okay, this one is a total magnetic wave. Okay, find epsilon r, w and e vector also, not only e, it may be e vector. Okay, so here h vector is given. So okay, so it's a electric wave, sorry, it's a magnetic wave, and the magnetic wave is present in which direction? Okay, you can see it's not only present in the only one direction, either x or y. It is present in both the direction. One of the component is present in the x direction and the second component is present in the y direction. Okay, but if you notice, the frequency of both the component must be same and the propagation direction is also same. So this wave, this magnetic wave is propagated in which direction? It propagated in positive z direction. Why positive? Because here is a negative sign. Okay, see here it is minus, so we say that this wave propagate, this wave travel in positive z direction, but the component of wave is present in x as well as y direction. Clear? Okay, So we can say that h vector is equal to h1 plus this term h2. h1 is this one and h2 is this one. Clear? Okay. So first of all, what we have to find out? We have to find out epsilon r. Epsilon r means it's a relative permittivity. Okay. So here we know that eta is equal to under root of j omega mu plus j omega epsilon, but sigma is 0 because it's a lossless medium, so conductivity is 0. So if you put 0, j omega cancel out, mu epsilon, and it is mu 0 mu r epsilon 0 epsilon r. Okay, so again I have to write mu 0 mu r epsilon 0 epsilon r, put value of mu 0 and epsilon 0, so this 120 pi under root of mu r by epsilon r. Okay, so it is 120 pi under root of mu r value is given 1, and we have to find out only one value, which is epsilon r, and eta is given, which is 60 pi. Okay, so 60 pi is equals to 120 pi divided by epsilon r. Okay, so under root of epsilon r is 120 pi divided by 60 pi, so this 2. Okay, so what is epsilon r? 4. Epsilon r is 4. Yeah. Next, omega. Oh, next find out the omega. Okay, so how can you find out the omega? Because epsilon r is given, mu r is given. Okay, so we know that beta is equals to, this is our standard equation for beta is equals to 2 pi by lambda, multiply denominator and the numerator with f, so 2 pi f means omega, lambda f means it is velocity v. Okay, now so we want to find omega is equals to beta into v. Okay, omega is equals to beta into v. Where is beta? Okay, so in this data the beta is given. Omega t, actually the standard equation is cos omega t minus beta z. Omega t minus beta z. So of course the beta value is 1. Okay, so 1 into v, and what is v? V is velocity of wave. Okay, which is 3 into 10 raised to 8 divided by mu r epsilon r. Because here the wave is not propagated in free space, the wave is propagated in lossless medium. Okay, if it is given the free space, so eta is 120 pi, mu r is 1, and epsilon r is also 1, but it is not given. Okay, so it is 3 into 10 raised to 8 divided by mu r value is given 1, epsilon r that we have to find out, which is 4. Okay, so answer is 3 by 2 into 10 raised to 8 means 1.5 into 10 raised to 8 radian per second. Okay, so this is the value of omega. Clear? Okay, now the main thing is how to calculate value of E, how to find out E vector. Okay, so here what we have to do? Okay, so H is given, so we have to split this H into 2 parts. So I have to say H is equals to H1 vector plus H2 vector. Okay, so similarly I have to find E is equals to E1 vector plus E2 vector. Okay, so here what is H1 vector? So H1 vector is given, which is minus 0.1 cos omega t minus z, in which direction? In x direction. So what we have to find out? From H1 we want to find what is E1. Similarly H2 is equals to 0.5 sine omega t minus z ay. Okay, so what we have to find out? We have to find out the value of E2 from H2. Okay, how? We know relationship between H and E. What is the relationship between H and E? E is equals to H into eta. Okay, you can write in terms of vector, E is equals to H into eta, or E1 vector is equals to H1 vector into eta. Eta value is given 60 pi. Okay, so E1 is equals to H1, this one, into 60 pi. But now the most important thing is the direction of H and the direction of propagation. Okay, and the direction of E1. Okay, so here we have to apply this equation. Propagation is equals to, propagation direction is E cross H direction, or pointing vector direction or propagation direction is equals to, so propagation direction is E cross H, so propagation direction is the Z direction, E cross H1 direction. H1 direction is minus AX direction, so this minus AX. Why it is negative? Because here minus 0.1 is given, so minus AX direction. Okay, so this AZ is equals to E cross AX. So what should be E direction? E direction is always in Y direction. Okay, so that is why E1 direction, so E1 is equals to, if I have to multiply this H1 with 60 pi, so it is 6 pi cos omega t minus z, in which direction? In Y direction. Clear? Similarly for E2. Okay, so here E2 is equals to, we can write in this way, E2 is equals to H2 vector into eta. What is eta? Intrinsic impedance is given, which is 60 pi. Okay, we have to put the same value, 60 pi. But now the question is, what is the direction of E2? So again we have to use the same equation, which is propagation direction or pointing vector direction is, okay, now here it is 2. Okay, so the propagation direction is the same in the positive Z direction is equals to E2 direction cross. Now direction of H2, here it is positive 0.2, so H2 direction is positive Y direction. Okay, so now E2 should be in which direction? In X direction. Okay, so therefore E2 is equals to 0.5 into 65, which is 30 pi sine omega t minus z into AX. So finally what we have to find out? E vector. So E vector is equals to E1 plus E2 vector. Clear? So this one is our example number 3. Next, example number 4. So number 4 is a plane wave in a non-magnetic medium. Again, the medium is a non-magnetic medium. Non-magnetic means relative permeability is 0. Okay, sorry, it's unity 1. A plane wave in a non-magnetic medium E is equals to 50 sine 10 raised to 8t plus 2z AY volt per meter. Find the direction of wave, find lambda, wavelength, frequency, relative permittivity, and value of H, okay, or value of magnetic field. Okay, so we follow last example number 4. Okay, what is given here? E is given, so E is 50 sine 10 raised to 8t plus 2z AY. Okay, so in which direction electric field is present? Electric wave or electric field is present in the Y direction. And which one is the propagation direction? The propagation direction is minus Z direction. Okay, see again I have to compare it with our original equation. Okay, our main equation or standard equation, E of ZT is equals to E0 e raised to minus alpha Z cos or sine, you may write anything, omega t minus beta z into AX. Okay, so here from this equation we can say that this electric field is, okay, electric field is present, means the direction of electric field is X direction, but the propagation direction is Z direction, because here it is minus, so propagation direction is positive Z direction. If it is plus, so propagation direction is negative Z direction. Okay, so here plus 2Z is present, that means the propagation direction is negative Z direction. Okay, so electric field is present in y direction, but the direction of wave propagation is negative z direction. Okay, now you have to just compare these two. So value of alpha is equals to 0, value of alpha is 0. That means no attenuation. That means the conductivity is 0. Okay, what is the omega? Okay, so again omega is equals to here 10 raised to 8. What is beta? Okay, you cannot write beta is equals to -2. Okay, because it's a phase constant. Okay, there's never a negative sign. Okay, so beta is equals to 2. Okay. What we will find first? We have to find out the direction of wave propagation. Oh, so direction of wave propagation is equals to, in which direction the wave is propagate? Minus z direction. Wave is propagate in the minus z direction. B. What we will find out? Lambda. Okay, we know that beta is equals to 2 pi lambda. So therefore lambda is equals to 2 pi by beta. Beta is given, which is 2. So value of lambda is pi meter. Okay, is meter because the unit of lambda is meter. Okay, next f. Again we know that beta is equals to 2 pi by lambda. Okay, or okay, it's a non-magnetic medium. Okay, so we have to find out the frequency. So omega is given, so you can easily find out the value of f. No need to do this whole thing. Omega is given. Omega is equals to 10 raised to 8. Omega is equals to 2 pi f 10 raised to 8. So f is equals to 10 raised to 8 divided by 2 pi hertz. It's very easy. Then what you have to find out? You have to find out the epsilon r. Epsilon r means relative permittivity. How can you find out the relative permittivity? So we use beta is equals to 2 pi by lambda. Okay, so this 2 pi f into lambda f. 2 pi f means omega, lambda into f means velocity. Okay, so we have to more focus on the velocity v omega by beta. Omega value is given 10 raised to 8. Beta value is also given, which is 2. Now what is velocity? Velocity is 3 into 10 raised to 8 upon mu r into epsilon r, but mu r value is 1 because the medium is a non-magnetic medium, so value of mu r is 1. So this only epsilon r 10 raised to 8 by 2, 10 raised to 8, 10 raised to 8 cancel out. So epsilon r is equals to 6. Root epsilon r is 6, so epsilon r is 36. Okay, and last final, see h vector. Okay, so we know relationship between E and H. Okay, what is the relationship? Okay, so before finding H, first of all we have to find out the intrinsic impedance. Okay, so intrinsic impedance is under root of mu by epsilon. So this 120 pi mu r by epsilon r. Mu r is 1 by epsilon r, 36. Okay, so 120 pi by 6. Okay, so this 20 pi. So eta is equals to 20 pi. Why we have to find out eta? Because we know that E is equals to H into eta. So to find out the value of H, we need eta. So H is equals to E by eta. So H vector is equals to E vector, which is given. Okay, it is 50 sine 10 raised to 8t plus 2z divided by 20 pi. But what is the direction of H? See here, in this case the direction of E is y direction, the propagation direction is z direction. So we have to apply our formula. Our formula is the propagation direction is equals to direction of E cross product with direction of H. What is the propagation direction? Propagation direction is minus z. So minus z is equals to E direction is a y direction. So what should be the H direction? Okay, so H direction is a x direction. It should, okay, actually it's not minus ax because minus sign is already present here. Okay, so this a x direction. So H is in the x direction. So this is in the a x direction, ampere per meter. Clear? Okay, so in today's class we have to solve these 3 numericals which is based on electromagnetic wave propagation. So here we have complete our chapter which is uniform plane propagation. Okay, so In last video class, we'll discuss about the next chapter, which is based on electromagnetic wave in a different medium. What is SWR, what is voltage standing wave ratio, what is reflection coefficient and transmission coefficient. Okay, thank you.